Hello Year 7, hopefully you've had a time to discuss this image with your teachers. If not, you can access it from the Padlet. Hopefully you're having a lovely day and are ready to start your science lesson. Today's lesson's title is Balanced and Unbalanced Forces. So please make sure you have this and today's date written and underlined at the top of your page or piece of paper. What are balanced forces? When two forces acting on an object are equal in size but act in opposite directions, we say that they are balanced forces. If the forces on an object are balanced, or there are no forces acting on the object, it's a stationary object would continue to be still, and a moving object continues to move in the same direction at the same speed. So I'm going to do an example. You don't need to write anything down for this. It is an I do. So there is a heavy book. It's sitting on a table. It is not moving, so the forces are balanced. We can show the force exerted by the earth on the book, which is the weight of the book due to gravity, using this arrow here. So that is a force arrow, and it shows the force exerted by the earth on the book. We can also show the reaction force that's exerted on the book by the table, and that is this blue arrow here. So the book is pushing down on the table because of gravity, and then the table is pushing back on the book. And we can summarise this in one diagram. As you can see, the forces are both equal in size and opposite in direction, so we call them balanced, and the book is still. We do. Have a go at drawing this little sketch out and having a go with me. So, Sam and Pat both want to have the same book. Both are pulling on the book, but it is not moving. We can show the force exerted by Pat on the book, and that's the arrow we have here. So pause the video and draw your diagram. Label your force arrow force exerted by Pat on the book, as written here. Now that you've drawn the force exerted by Pat on the book, we can show the force exerted by Sam on the book. So we're going to have an arrow going towards Sam. And hopefully you'll have a diagram that now looks like this, because as you can see, the forces are both equal in size and opposite in direction. This means the forces are balanced and the book is still. Okay, have a go at this example on your own. So, step 1. I've shown you this arrow to give you a start. So the boat's engine is off and it is stationary, which means it's not moving in the water. The boat is floating. So step 1. Draw an arrow showing the force exerted by the earth on the boat. Step 2. Draw an arrow showing the force exerted by the water on the boat. Pause the video and make sure you've got your 2 arrows. The first one has been done for you. Here would be our second one, so this is the upthrust of the water. So that's the force of the water pushing on the boat. And you should end up with this diagram. Make sure you check that the forces are equal in size and opposite in direction. It doesn't matter what size you drew your arrows, so long as they are both the same. Okay, next question. A spacecraft is drifting through space. It is very far away from all other objects. There is no air in space, so there is no air resistance or drag. The spacecraft is moving in a straight line at constant speed. Are there any forces acting on the spaceship? If so, draw them in. pause the video here while you have a think about that question. Are there any forces acting on the spaceship? So, there were no forces acting on the spaceship. We can tell that because there was no air resistance. And if there was any force acting on the spaceship, it would no longer be travelling at a constant speed or in a straight line, because there would be no air resistance to balance that force. So we need to remember that when we talk about balanced forces, there's either balanced forces or just no forces. And as well as an object staying stationary, which means still, it can mean that the object continues to move in the same direction at the same speed. So when we actually launch rockets into space, if we turn the rocket off, or a satellite, there's no propulsion from an engine anymore, if we turn it off, it will continue to travel in the exact same direction and the exact same speed forever, because space is a vacuum. There are no particles, so there is no air resistance, so there's no force that's going to change its direction. Okay, next question. What are unbalanced forces? When two forces acting on an object are not equal in size and opposite, then they are described as being unbalanced. The overall force acting on the object is called the resultant force. When the forces are balanced, the resultant force is 0. So, if forces on an object are unbalanced, then a stationary object starts to move in the direction of the resultant force. A moving object will change speed and or direction in the direction of the resultant force. This change in motion of the object depends on the size of the resultant force and the direction of the resultant force. Resultant forces. The greater the resultant force, the greater the change in motion. Whether an object speeds up or slows down depends on the direction of that resultant force. The object will speed up if the resultant force acts in the direction of movement, while the object will slow down if the resultant force acts opposite to the direction of movement. For example, if you've got a skateboard rolling down a gentle slope, if I have a resultant force, me pushing, in the same direction as that skateboard, it's going to speed up. If I gently push it in the opposite direction, the skateboard would slow down. So, we can calculate resultant forces. So I'm going to go through an example. You do not need to write this down. The resultant force is the single force that could replace all the forces acting on an object. And we find these by adding them together. If all the forces are balanced, the resultant force is 0. So let's have a look at this question. So what is the total force pressing downwards because of weight? So we've got 60 newtons on the left and 60 newtons on the right, which totals to 120 newtons. What is the total force pushing up? The reaction force. It's 120 newtons. So we find the resultant force by doing the force in one direction, the biggest force, minus the force in the other direction, and that gives us the resultant force. So for this example, we would have the 120 newtons going down minus the 120 newtons going up, for an answer of 0 newtons. So in this scenario, the forces are all balanced. Okay, this is a we do, so have a really quick sketch of a stick man and a parachute and draw on these arrows for me, please. First step, what is the total force pressing down? So in this example, it's 80 newtons. The next one, what is the total force pushing up? In this case, because of air resistance. So that's 35 newtons. So we can work out the resultant force by doing the force in one direction, the bigger one, minus the force in the other direction. So we're going to do 80 newtons, which is the force down, minus 35 newtons, the force up, to give us the resultant force of 45 newtons down. Okay, there are some examples on the next few slides. Pause them at each one and tell me the size of the resultant force and the direction of the resultant force. Here is the first one. Here is the second one. Here is the first one. This one's a bit trickier. Make sure you consider up and down separate to left and right. So consider these two arrows, then consider these two arrows. There is an optional challenge question if you're feeling really brave. Have a go at this question, and again, do these arrows first and then consider this arrow. Here are the answers to those questions. So for the sea lion example, the answer was 0 newtons, the forces are balanced. For the cars, it was 300 newtons moving from the right to the left. So the overall arrow would be like so. For the surfer, the up and down forces are balanced, whilst the left and right forces, there is 110 newtons, again going from right to left. That'd be 110 newtons. And then for the kind of circus act, if we look up and down, there is just 45 newtons going down. And then from left to right, there is 1,585 newtons going to the left. Okay, can you complete this quick quiz in your books or on some paper, please? Pause the video and answer these 4 questions. Okay, that's the end of today's lesson. Really well done, Year 7. Make sure you take a picture of today's work and upload it to Teams so that your teacher can see it. Be really pleased with yourself. This is really quite difficult and I'm sure you're all doing an amazing job.